Okay, so we want to put all these coordinates on the unit circle here. And let me change my color. Green doesn't show up too well. This bar is constantly in my way. Okay, so 0 degrees radians, degrees is the same as 0 degrees radians. 30 degrees is the same as pi over 6 radians, right? 45 degrees, how much is that? Well, let's do the quarter angles first. Maybe that'll help you. How much is 180 degrees? Cross that out. I put the pi. 180 degrees is the same as pi radians, right? So how about 90 degrees? What is that? Halfway in between 180. So half of pi radians is pi over 2 radians. And we know the coordinate. What's the coordinate at the top of the unit circle? Unit circle means radius 1. So what's this coordinate? If this is 0, 0, and we have radius 1, what is that coordinate at the top? This, I believe, one of these questions was on the 11th grade end of year exam. So if you took that, hopefully you saw the question that had, yes, good. Elizabeth says 0, 1, and she's correct. That's 0, 1. And they asked what the sign of pi is. I believe pi or pi over 2. Well, this would be, if I asked what is the sign of pi over 2? Okay, so this is pi over 2. What is the sign of pi over 2? Is it 0 or is it 1? It's 1 because we know the unit circle. Okay, the first coordinate is your cosine, always cosine theta. The second coordinate is your sine for the unit circle. So that works out for any of the points. So cosine is 0. So if I asked you what don't write this on your paper, write this on a separate sheet of paper. I'm going to erase this stuff. We just want the coordinates on here. So this is just like extra stuff. Cosine of pi over 2. The cosine of pi over 2 would be whatever the x coordinate is, which is 0. Okay, if you put this in your calculator, if you were in your calculator, what mode would you have to be in your calculator to get these answers? You'd have to be in radian mode. So you have to change your calculator to radian mode. You have to put sine of pi over 2 in your calculator, and then you will get 1. If you're in degree mode, if you stay in degree mode and you put sine of pi over 2, you're going to get some completely different answer, okay, because it's not in the right mode, because you're doing radians. This is a radian. If it has a pi in it, it's usually a radian, right? So you want to be in the correct mode, and you're going to have to switch back and forth a lot between radian mode and degree mode. If I give you, let's say, find the cosine of 180 degrees, okay? Should you be in degree mode or radian mode for this one? You should be in
radian. Oh, degrees, sorry.
Exactly. So you need to change your calculator to degree mode. So I'm going to get my calculator out. Let's see what mode I'm in. I am in degree mode. And if I put cosine of 180, cosine 180, if any of you want calculators in class, you're welcome to borrow any of those up there. Cosine of 180, wow, what does it give you? Oh, I'm in radians. I was going to say, it's giving me negative 0.59. I know that is not the cosine of 180, right? So what's the problem? My calculator is in radian mode. So I need to change. I need to press the DRG button, right? The DRG button right at the top next to the second button. And I need to select degrees, enter. And now I press it. Now it's giving me -1. I know that's the correct answer because 180 is over here. What is this coordinate over here, guys? If this is 0, 0, radius 1, what is this coordinate right here? -1, 0. So this tells me, hey, the cosine of theta is -1 and the sine of theta is 0. And if I put in my calculator, it'll confirm that when I'm in degree, or, well, I have to be in degree mode, okay, for that to be correct. Okay, so I'm gonna erase this stuff so I have more room to write over here. You guys can copy down anything you need to copy down over here. So I know some people had this blank because they got copies from me, so you might want to copy that down. Okay, so just to reiterate, the first coordinate is your cosine. The second coordinate is your sine. And another way we could write that is we could, we could write xy, backwards, undo, go away button. Okay, so x comma y, right? So it means the x coordinate, x is your cosine, right? And y is your sine, always. Don't get these backwards. Someone got this backwards on something I saw somebody turned in. Okay, and hopefully most of you 11th graders did the end of year exam. Thank you for doing that and getting that out of the way. And now we can say we did it and move on, and it doesn't count for your grade, but it's something that our school needed to fulfill for state testing requirements. So thank you for, I saw 42 people did it on Sunday, so that's awesome. So some other classes have difficulty, but you guys came through, so thank you for helping Maria Creel fulfill their requirements to remain credentialed. Okay, so we have two of these coordinates here. If you didn't write these, this comes from our 30. Don't write this on your paper, but just, I don't want to clutter up your paper, but just look at this. This is 30, 60, and then we have 90 down here, right? And so this is 1/2. This short leg is always going to be 1/2 for any 30, 60, 90. So we're going to repeat that all the way around the circle. Okay, so if we learn this 1, 30, 60, 90 triangle, it's going to help us find most of the coordinates on the circle, like 3/4 of the coordinates around the circle. Okay, so if this short leg is always going to be 1/2 for a 30, 60, 90 triangle in the unit circle, just for the unit circle, not anything else, right? This coordinate is going to be √3/2 because it's the longer leg, right? So the longer leg is always √3/2. And we talked about why that is last class period. The radius, we know it's a unit circle, so it has to be 1. So that's why this is your x and this is your y, right? This distance right here is your x, and this distance is always going to be your y. So that is how we get the coordinates on the unit circle. And we don't want decimals. If you put this in calculator, if you give me 0.866, I'm not going to count that, okay? Because we want only exact values. That's why we're doing this now. We said you can use this sheet on the test, on the homework. You can use this sheet. Okay. Next year you'll have to memorize it, but this year you get to use the sheet. Okay. So no decimals, and so that's how we get this coordinate. When we do the 45, 45, 90 triangle, when I do this triangle right here, this one's a 45, 45, 90 triangle, right? And for that, the x coordinate goes from here to here, and it's √2/2, and the y coordinate is the same. It's √2/2, because this is an isosceles right triangle, right? If you have 45, 45, 90, 45, 45, you can do this on a separate sheet of paper. Don't clutter up your paper. This is √2/2, and this is √2/2, because this is 1. So we did that last class period. I made this x, I made this x. I said x plus x squared plus x squared equals 1 squared. I used Pythagorean theorem, and then we found x to be √2/2. Okay, so there's 4 45-degree angles in here. There's this one, there's this one, right? There's a 45, 45, 90 here. There's this one right in the middle. How do you know the 45, 45, 90s? Because it's right in the middle. Because this is 90 degrees. Oops, this is 90 degrees right here, and it's right smack dab in the middle. So that's going to be your quarter angles. So if I look at this 90-degree angle, the one that's in the middle is going to split these two. It's right in the middle of those two. And you always draw your perpendicular up to the x-axis, never to the y-axis, okay? So your perpendicular goes up to the x-axis always, never to the y. And so this side is √2/2 right here, and this is -√2. So I can fill that in right now. √2/2 and -√2/2, right? For that coordinate 315 degrees. And then down here is the same coordinate, except it's going to be negative, right? Because any coordinate down here is going to be negative. So -√2/2, -√2/2. So what is the cosine of, so if we ask you on a test, which we are going to do, right? If I say, what is the cosine of 225 degrees or 5π/4, whichever one I want to ask for, you just look at your unit circle and you say, that's the cosine. So the cosine is -√2/2. or the cosine of 5/4 pi is negative root 2 over 2. I didn't need to put in my calculator. I didn't need to calculate anything. All you need to do is look at your unit circle. Okay, so that's why we're filling this out right now. And then of course, this one up here is my other 45. So this one is going to be negative root 2 over 2, positive root 2 over 2, right? Because we go negative, this is a negative x, a positive y. So negative, positive. So that's the coordinate for 135 degrees. Okay, I'm going to erase all this because it's getting sloppy. And then we'll do all the other angles. We'll do the 120, the 150, the 60 we'll finish up. We'll do the 210, the 240, 300, and the 330 and fill those in. Okay, so I'm going to erase these just because it's pretty messy. Okay, so we did all the quarter angles, right? We did this one. We did this one. This one. I should use my line tool. That one and that one. So I don't need to do those. So now I need to do all the other ones. Okay, so we did these two already. This again is just a 30, 60, 90. We dropped a perpendicular down here. This is your x coordinate. This is your y coordinate, right? How far you go over is your x. How far you go up is your y. So what is x? It's the short leg. What did I say? How long did I say the short leg is, guys? It's a half, right? It's 1/2. And then the long leg is going to be the bigger square root number is root 3 over 2, which again is 0.866, but I never want to see that on a test or quiz. You give me that, you get 0 points. You give me this, you get full credit. And it's just multiple choice. You get full credit or no credit. Okay, I see a decimal, no credit. Okay, so this triangle right here is the exact same triangle as that triangle, right? So it's just flipped around. So this is a negative x. I go how far over and how far up do I go to get my coordinates over here? Well, same x coordinate. It's just negative 1/2, right? It's the short leg and this is the longer leg. So positive root 3 over 2. Same coordinate, except the x coordinate is negative in this quadrant. Okay. Now I want to do this 150-degree angle. I'm going to drop a perpendicular down here. And this is the long leg this time. So my negative x goes all the way out here. My positive y goes up here. So this is negative root 3 over 2, positive 1/2 for 150 degrees, which in radians is 5 pi over 6. And we didn't fill that in. So we filled it in on the other sheet. All these are on the other sheet. So you can fill all these in from the other circle that we did. Okay, this is like pi over, we already filled that in. That's 90 degrees and so on. Okay. Okay, I did this one. I did this one. That was in the middle. We did that one already. All the quarter angles are easy to remember because it's all root 2 over 2, root 2 over 2. They match. They're the same. Okay, so that was the 135 degree. Okay, so when I come down here to do this triangle, that's going to be super easy because it's the reflection of this triangle, right? Right, so it's going to be the same coordinates of this, except one of the signs is going to be different, right? Because I have a negative x over here, and what about my y? Is my y positive or negative? It's negative, so it's going to be the exact same coordinates, but negative. Negative root 3 over 2, negative 1/2. Okay, because this is the long leg, this is the short leg. So the long leg is always root 3 over 2, but negative. And then this is the short leg, which is negative 1/2. Okay. So when I come down here and I do this, gotta get this out of the way. When I come down here, this triangle is still a 30, 60, 90. This is my 30-degree angle. This is my 60-degree angle. This is my 90-degree angle. Same as over here, right? Just going to be negative, negative. I got the short leg, right? We're going over the short leg and down. So my x is negative. My short leg is negative 1/2. And my long leg is negative root 3 over 2. So that's the coordinate down there. So do you see how, like, you don't have to memorize all these? Like, you can see where you can draw the little triangles in your head or your paper, and you can see, oh, this one's short and this one's long. So negative short leg, negative a half, long leg, negative root 3 over 2. So it's easy to, you don't memorize the unit circle, you just memorize one little triangle and it gives you all the coordinates around the circle. So when I go to the 300-degree angle here, okay, so when I go to 300-degree angle, I drop a perpendicular down here. It's the exact same as this one up here, but let's see, I'm going to the right, so that's positive. I'm going down, so that is a negative y. So this coordinate down here should be positive, negative, right? So short leg, I got a short leg and then I got the longer leg here. So positive 1/2, negative root 3 over 2, right, is the 300-degree angle. So if I ask you on a test, what is the cosine of 300 degrees, right? You look at your unit circle and which one is it? It should be a half, and your calculator will put 0.5. Don't give me 0.5, give me a half, because we put a half on your paper. Your calculator gives you 0.5. Try it in your calculator. Cosine of 300. I got my calculator here. Cosine 300 degrees. Am I in degree mode? Yes, I am in degree mode. Gives me 0.5. Okay, so we've confirmed our answer that the cosine of 300 is half. If I put a sine of 300 in my calculator, sine of 300 degrees, it gives me negative 0.866. And it reminded me it was negative, right? Negative 0.866. I don't want the decimal answer. I want this answer. Negative 0.866 is the same thing as root 3 over 2. Okay, so those three you should memorize. There's another one. What is root 2 over 2? Okay, let's do square root of 2. I think is that 0.707? I think this is the one, right? If I remember, yeah, 0.7071. So I'm going to do that just to see. Square root of 2, clear. Square root of 2, enter, divided by 2, enter, is yes, 0.7071. So your calculator is going to give you, they're only going to give you 3 decimals. They're going to give you this decimal, they're going to give you 0.5, and they're going to give you 0.866. Easy for you to translate that. 0.866 is root 3 over 2. 0.5 is 1/2. 0.7071 is root 2 over 2. That's it. That's every value except the negative 1 zeros, except those should be easy ones, right? And this one's positive 1 0, and 270 should be 0, negative 1. The quarter angle should be easy. We're assuming you know those, although I shouldn't make that assumption because I made that assumption and people didn't know that on the first, but by now you should know it because we've covered those quarter angles a few times. Okay, question, Kyle, you raised your hand?
Yeah, so this.
You might have to type it in the chat because you just cut out. Yeah, just type it in the chat. Any questions from you guys in class while we wait for Kyle to type his question in the chat? Anything you're not sure about? Feel free to ask questions. Feel free to stop me. I'm making a video and I'm zooming, but I'm talking to you guys too. So stop me anytime. Raise your hand. Say, hey, Miss Wakefield, I have a question. Did a chat come up? I didn't see a chat come up, did it? Oh yeah, there it is. Okay, if cosine is the x value and sine is the y value, what is tangent? Good question, great question, because that's the rest of the lesson for today. So what is tangent? Anybody remember from last class period what tangent is? We defined it last class period. Let me see, I want to go to the next screen here. Okay, go to the next screen, Google slide. Google slide doesn't like me. Okay, ignore this other stuff. I'm just looking for some blank space here. I got a blank space, baby. Okay, tangent theta. I like Taylor Swift. Tangent and theta, we defined this last class period. What is tangent? It's something divided by something.
Cosine divided by sine.
Good. Sine of theta divided by the cosine of theta. That is the definition of tangent. That is how you find tangent. Well, don't we know the sine and the cosine of every angle around the unit circle? So you can find the tangent. So I can ask you, and I will ask you on the next quiz, the tangent of any angle. I'm not going to ask you every tangent, but I'm going to pick like 2 or 3 tangents, 2 or 3 angles on the quiz. And I'm going to ask you, hey, what's the tangent of 30 degrees? Or what's the tangent of 5 pi over 6? Or what's the tangent of 3 pi over 2? Okay, and all you would do is take the sine divided by cosine. Do I want a fraction or a decimal? I want the fraction answer in reduced form, right? So I need to erase this and go back to the unit circle. Okay, erase some of this, and some of this. Okay, and I want to go back to the other screen, go backwards, Google Slide, work with me, Google Slide. Okay. That's annoying. Okay. So let's say I want to find the tangent of 30 degrees because we haven't, I think I did one last class period, but we only did one, right? So I was going to say I didn't do any, but I think we did one, but let's do a couple examples. Let's find the tangent of 30 degrees or the tangent of, that is pi over 6. Tangent of 30 is pi over 6. Okay. Well, I would take the cosine and divide it by, I'm sorry, the sine and divide it by the cosine. I got that backwards. It's the sine theta divided by the cosine theta. Another way you can remember it, it's the y divided by x, which is also known as, simply known in algebra 1. What is the y divided by x in algebra 1? Same thing as the rise over the run, or more commonly known as the slope. Okay, slope. So tangent is the slope of this line. So if I draw like this line right here, does that line have a slope? Yeah. And guess how we find the slope of that line? We go the y over the x. So I just use the unit circle and I just do the y divided by x. So let me get my pen back. So I'm going to do, I could write it like this, 1/2 divided by root 3 over 2, but this like confuses the heck out of people. They're like, oh my gosh, what did you do? This is like a super fraction. Okay, let's just make it like this then. Okay, let's do elementary school. 1/2 divided by root 3 over 2. Okay, oh, okay. I know how to divide 2 fractions in 4th, 5th grade. We learned that you take the first number and you multiply by the reciprocal. So you change this to multiplication and you flip this over. And so it's 2 over root 3. Okay, you cross reduce where you can. The 2's can cross reduce. So we'll go ahead and cross reduce that. And we get 1 over root 3. Okay, and normally I would tell you to get rid of the root 3 in the bottom, but I'm not going to. I'm going to let you leave a square root for once in your life. Okay, you're allowed to leave the square root in the denominator just for tangents. Okay, so the tangent of 30 degrees is 1 over the square root of 3. Okay, that's some decimal. I don't care about the decimal. I don't want a decimal. I want 1 over square root of 3. So if I look for this line, this line right here, that has a steeper slope, right? This one has a steeper slope. So if I do the tangent of 60 degrees, change colors and get a pen back. Okay, if I do the tangent of 60 degrees, then I'm going to do the y over the x equals y over x. So 60 degrees, I'm going to do root 3 over 2 divided by 1/2. This divided by that. Okay. So that's going to give me root 3 over 2 times, and I'm going to flip this over, multiply by the reciprocal, 2 over 1. Again, the 2's are going to cancel, and this time it's just going to give me root 3, because root 3, you know, over 1, I don't need that over 1 part. So the tangent, so this tangent is square root of 3. Well, hey guys, if this is, look, they're reciprocals of each other. This tangent is 1 over square root of 3. This slope is 1 root over root 3. This one is root 3. Guess what this one is? And guess what this one is? You think they're related to those? Yeah, this one should be what? Same slope as that, but negative, because it's a negative line. Exact same line as that one. This is the reflection of that line. This one is going to be same slope as this, but opposite direction. So this one should be negative 1 over root 3. Can you calculate it? Can you just take this and divide it by that? Yeah, you can always calculate it. And I should see that work on your paper for the quiz when you turn in the quiz. So I would say 1/2 divided by negative root 3 over 2, and I get negative 1 over root 3 for that slope. Now let's talk about some special slopes that we haven't talked about that we need to talk about. And that is the slope at the top. Let me erase. I'm going to erase a bunch of this, guys, because I just don't need all this. Okay, let's talk about the slope, or the tangent, in other words, of like 90 degrees. Okay, this 90-degree angle up here, right? 90 degrees. What is the tangent of this? Tangent of 90 degrees, or pi over 2. Let's get used to our radians, okay? Your brain should translate. 90 degrees is pi over 2. You should know your radians now around the circle, especially your quadrant angles, the top, the left, the bottom. You should know those. Pi over 2, pi, 3 pi over 2, 0 or 2 pi. And then keep going. This, if I add another 2 pi, this is going to be 4 pi. If I add another 2 pi, do another revolution, that's going to be 6 pi. If I do another revolution, that's going to be 8 pi. So any multiple of 2 pi is going to be at 0, right? So if I ask you for like the tangent of, let's say 10 pi, that's 5 revolutions, or no, well, yeah, 5 revolutions around the circle. If I do 5 revolutions around the circle and I end up here, what is the tangent here? Well, it's the slope of this line, right? So the tangent of 10 pi, this coordinate over here is 1, 0. So I'm going to take the y divided by the x, or take the y is 0. 0 divided by 1. Right? What is that going to give us? 0. Don't leave it 0 divided by 1. You'll get 0 points. 0 divided by 1 is 0. But the slope of a horizontal line, if you remember from math 1, is 0. Okay, so now let's talk about the slope of this line right here. I want to do this tangent of 90 degrees, or what is 90 degrees in radians, guys? Pi over 2. If I want to find the tangent of pi over 2, I put my calculator in radian mode, but I don't want to use my calculator. If you put this in your calculator, it should give you some kind of error, right? Because I'm going to do y divided by x, 1 divided by 0. Never leave your answer like this. You have to tell me you know what this means. What is 1 divided by 0? What should we put for that? Who knows? I'm not going to tell you. Somebody tell me what 1 divided by 0 is.
Undefined.
Thank you. Is that Mateo?
Of course.
Of course. It's good to have you, Mateo. 1 divided by 0. Because I appreciate you just talking. 1 divided by 0 is undefined. So the slope is undefined. Does that make sense that the slope of this line is undefined? Because it's straight up and down, right? And you can't divide by 0. And we know that vertical lines have an undefined slope. So you need to write that the slope is undefined. You need to show me the work by doing 1 divided by 0, not just giving me undefined or whatever, you know, whatever math software tells you. And you need to show me that, okay? That's how you know it. So if I do, this is 3 pi over 2 down here, right? So this is 3 pi over 2, 270 degrees. So if I say I want to find the tangent of 3 pi over 2, or 3, so I'm writing that wrong, 3 pi over 2, that's going to be -1 divided by 0, right? But I don't want to leave the answer like that. You need to translate. You need to tell me, is this 0 or is this undefined? This is undefined because you cannot have the 0 in the denominator. You cannot divide by 0, but you can have 0 in the numerator. It's okay to have 0 divided by 1 over here. That's 0. And that's a 0 slope. But this is an undefined slope because the 0 is in the denominator. 0 in the numerator, okay. 0 in the denominator, not okay. Okay, so the slope down here is also undefined because it's the exact same line as the one up there. That line is the same as that line. So it makes sense that both of those slopes are undefined. Okay, this is going to be a positive slope right here. This is going to be a positive slope. Oh, let's talk about that one. Any of these ones. We didn't talk slope of 45. So let me, sorry, this is so cluttered. I'm going to erase some of this. It's good stuff we're doing today. Finishing up the unit circle. You're going to learn it again next year, but if you remember it from this year, it's going to save you a lot of heartache. Okay, so the tangent of 45. What is 45 in radians, guys? This is pi over 2. What's half of pi over 2? Pi over 4. Okay, know your radians. Know what, if I give you a degree, you need to be able to tell me what radian that is. Okay, you can look at your unit circle. It's okay. You need to look at your unit circle a lot. You should be looking at it a lot. So tangent of pi over 4, well, the x coordinate or the y coordinate is the same as the x coordinate. So root 2 over 2 divided by root 2 over 2, well, if you have the same thing over the same thing, what does that equal? It should equal 1, right? If I have 5 over 5, that equals 1. Well, root 2 over root 2, that equals 1 too. So, oh, does that make sense that this slope is 1 to 1? Yeah, because if I have root 2 over 2, root 2 over 2, my slope is root 2 over 2, root 2 over 2. That's a 45-degree angle. Oh, we know this is a 45-degree angle, and 45-degree angles have a slope of 1. So that begs the question, what is this slope for this 45-degree angle going this way? That slope should be -1, shouldn't it? Because aren't we doing root 2 over 2 over negative root 2 over 2, which equals -1. So if I do the tangent of 135, tangent of 135 degrees, or what is that? That's 3/4 pi. So 3 pi over 4. I glanced over my unit circle for that one because I didn't know it off the top of my head, but that makes total sense to me. I shouldn't have needed to glance at my unit circle, but your unit circle is there, right? Use it. So tangent of 135, this angle right here, this is a negative slope. It's -1. Okay, you can show me the calculation by doing negative root 2 over 2 or positive root 2 over 2 divided by negative root 2 over 2 equals -1. Okay. So now you know how to find the tangent, yes, of any angle on the unit circle. I tell you to find me a tangent of 150, -1 over root 3. Okay, you can show me the calculations for that. I tell you to find me the cosine of 5 pi over 6. You look at your unit circle. Cosine of 5 pi over 6, -root 3 over 2. No calculations. I tell you to find me the sine of 315. Okay, take a look at your unit circle. What's the sine of 315 going to be? Well, positive, negative. So -root 2 over 2, right? It's in the middle. This is root 2 over 2, -root 2 over 2. It's the y coordinate. The sine is the y coordinate. I wrote it up here, but I erased it. So always remember the cosine is the x coordinate. The sine is the y coordinate. We wrote it up top earlier. Hopefully you have that on your paper. Okay. Any questions on that? That's it for the unit circle, guys. So you have to be able, I tell you the sine or cosine and you find it. I tell you find the tangent of this angle or this radian, you find it. Okay. And that's what you need to be able to do for the quiz on Wednesday for cohort A and distance learner and seniors. And then on Friday for cohort B. Okay. So that is the lesson for today. The other thing, so you can submit this into the notes. Let me get out of here. There's one more activity we're doing, so don't log off yet. You are going to submit that into A44 classwork notes right there. And there's a Desmos for you to finish. Let's say this is your classwork / homework, but this is actually due right now. So if you do this, I won't give any homework. How about that? Sound good? Because there is a worksheet. There's a 9.2 worksheet for me to give you, but I don't really feel like doing another homework, grading another homework assignment. And I don't think you guys feel like doing another homework assignment. So let's just say last day of class before final, no homework, okay? Just do this Desmos assignment. So the Desmos, you want to click on it. And this is a shorter Desmos than the other one. The other one was longer, but it's a little, this is going to help you with the unit circle for sure. So this is going to help me see if you understood what we just did. Okay, so that's what we're doing the rest of the class period. There's really 15 slides, well, actually 2, because these are just like, hey, do you know this and that? Okay, so yeah, go ahead and work on that the rest of the period, submit your work. And that is what we're doing for the rest of the period. Oh, let me end this recording.